equal to 2. The only correct answer is 2. Well, inequalities means that we can have many answers. There's like a section of answers. How old do you need to be to drive a car? How many? 16. 16 you can get your license. 15 you can start your driver training. Does everybody get their license at 16? No. No, 16 still in the States for driving. No. No. But you can be older than 16, right? And get your license for the very first time. I know lots of adults who haven't had their license and they went and got it. So you don't need to be 16. So the answer isn't 16, it's 16 and older, right? So I could be 42 and I could go get my license. I'd still be okay with getting my license at 42. So we've got a bunch of answers that work for that situation. It could be 16, it could be 17, it could be 42, probably not 100. I don't think when you're 100 you should go get your license. I think maybe that's not a good plan. So there's a whole set of things in here. So when we're dealing with inequalities, we're dealing with a range of correct answers. All right, so I put these symbols on the front of our booklet. And you guys probably know these from elementary school and you've done inequalities before. So if this symbol is greater than, the pointy part points at the smaller number, and the bigger part, the alligator, that's how I learned it. It was an alligator. It's eating the bigger number. How did you guys learn that? Same sort of thing? Just alligators. I don't know why in Thompson it's not like a polar bear or something, or a wolf. But the alligator eats the bigger number. So the pointy part points to the smaller number, big side points to the bigger number. The equal to sign, same sort of thing. It could be greater than or equal to. Now we're going to attach these to graphs as well. And like I'm doing this sort of stuff, we do inequalities all the way up to grade 12 pre-cal. So this stuff isn't going away, so understanding it at this level is important because this is the foundation of it. So if we were to do the driving age thing, so our age has to be greater than 16. Everybody agree? Could I be 16 and get my driver's license? You guys told me I could, right? So I would include the equal to sign. Oh, that's a really bad one, but you get the idea. So it means age can be greater than 16 or equal to 16. So that's for our driver's license, right? I can be 16 or above to get my driver's license. So what we're going to be doing today is we are going to be creating these inequalities. We don't know what the age is of the person, but any age greater or equal to 16, you can go get your driver's license. These symbols are also on the front cover. And I found this little table, and I know it's a little fuzzy. It's kind of hard to read. It comes out really nice when it's in color. It talks about open circles. We're going to be doing all these sort of things here. So this is why I put it on the front cover, so we could remember it. We know that the smaller number is the pointy one. The alligator's eating the larger number. I don't know if you've ever seen this symbol before, but it means not equal to, can't be equal to. We won't do too much with this one, but just it is a symbol in math that we use often. So all those symbols are there and they're in your notes, so it's really important. All right, so I have a parking sign. 30 minutes. I can park for 30 minutes, 9 a.m. to 6 p.m. Can I park for 35 minutes? What will happen if I park for 35 minutes? Probably going to get a parking ticket, right? Somebody's going to come along and give me a parking ticket. Can I park for 22 minutes? Yeah, I don't have to park for the full 30 minutes. 30 minutes is the maximum that we can do. So can I park for 30 minutes? Like, does 30 minutes count? Yes. Okay, so which one of these inequalities describes time in minutes for which I could be legally parked. So let's read these. Let's use words to read these. So this is time, whatever parking time is greater than 30. So that means the T is greater than 30. Does that make sense for this sign? You guys told me I couldn't park for 35 minutes, right? So this one, if I write that out, parked time is greater than that's what that's saying. Our park time is greater than 30 minutes. You guys told me if I parked for 35 minutes, I'm going to get a ticket. So that one is bad. I'm going to get a ticket. I can park for more than or equal to 30 minutes. Can I do that? No. This one says time less than 30 minutes. I can totally do that. That's good. Time is less than or equal to 30 minutes. So which one of these is more correct? The second one. This means I can park for 30 minutes or less. And that's really what the parking sign says. Hey, you can't park here for more than 30 minutes, but 30 minutes is okay. So now what we're taking is like everyday signage, everyday information, and we're turning it into a math inequality. So it's stuff that you know, and now we're just going to try to make these a little bit better, a little bit mathier. I like to think that that's better. Okay, so we're going to define a variable, which we've done before, and we are going to write an inequality for the situation. So the speed limit's 55. Can I go over 55? Maybe this is a better question. Can I legally go over 55? No. Okay. Can I drive 55? Yes. Can I drive less than 55? Yeah. The speed limit, it's the maximum. So I'm going to say S equals, so remember we've done these before, let S equal the speed. Let S equal the speed. And now we're going to write an inequality. So my speed has to be less than 55. And now the big question is, can it be equal to 55 legally? There we go. That's all we're doing. Easy peasy. All right, so it's nickel days, and there is a height restriction on the rides. Like some of the rides, you have to be a certain height in order to go on it because you might not fit in like the safety harnesses if you're too short. So height restriction, you must be at least 102 centimeters, so a little bit over a meter, to go on this ride. So can I be less than 102? No, I have to be taller, right? Like that's the minimum amount. So we're going to say let H equal height. So we know that height has to be greater than 102. Can it be equal to 102? Yeah, has to be at least. So that means 102 counts in my answer. So I have to be taller than 102 centimeters. And I think, ladies and gentlemen, I might be taller than 102 centimeters. So I could go on that ride. All right, on our milk container, store at temperatures below 4 degrees Celsius. It'll be fine outside today because it's below 4 degrees Celsius. All right, so if T is temperature, let T equal temperature. I have to sound it out in order to spell it. Let T equal temperature. So is T greater or less than 4 degrees? If it has to be below 4 degrees, less. Right? So the pointy part points towards the number that's smaller, and we're saying t has to be less than 4. Now, does it equal 4? So this one just says below 4 degrees. Does it include the 4? No, this one doesn't say anything about that. It just says it has to be less than 4 degrees, so it's got to be below 4. So we're going to leave the inequality like that. All right, last one. I'm sure you've seen these ratings before. Home video 14A rating. So what does that mean? Age. Okay, so there, we've defined our variable. Let A equal age. And what does that mean, 14A? How old do you have to be to watch the movie? 14. I'm older than 14. I'm 46. Am I allowed to watch the video? Yes. So A has to be greater than 14. Is it equal to 14? 14-year-olds, can they watch this video? Yeah. So it's got the equal to sign there. So you notice I do the kind of inequality first, and then I go back and ask the question, is that equal to? Morning, David. Starting our new unit today. Inequalities. Can you guys see that with the light on it? Do you want me to shut the blinds? You guys okay? All right, nobody's complaining. You should complain if you can't see it. All right. Okay, now we don't have signs, we have words. We have words. We're going to do the exact same thing. We're going to define that variable, define a variable, and then we're going to write an inequality. So we're doing the two things. So contest entrants, so people who enter a contest have to be at least 18 years old. So what's my variable? What am I talking about? What's this about? Age. So let's define our variable as let A equals age. Are you sure you don't want me to close those blinds? You guys can see okay? Yeah? All right, okay. All right, so you have to be at least 18 years old. So is A greater or less than 18? Greater, yeah. Can it be equal to 18? Yeah, you got to be at least 18. So voting in the next election, you have to be at least 18 years old to vote. So even though I'm over the age of 18, I'm still allowed to vote. But if you are 18, you are also allowed to vote. The temperature has been below -5 for the last week. And I didn't say -5, I said -5, because that's really what it is. So we're talking about temperature, so we're going to say let T equal temperature. So is temperature greater than -5 or less than greater or less than -5? If it's been below, less. Now, does it equal -5? All it says was that it was below. It didn't say it hit -5, it said it was below. So we're just going to leave our inequality like that. Okay, we're getting pretty good. I think so. I think it's not that hard. You must have 7 items or less to use the express checkout at the grocery store. Okay, so I'm going to say let N equal number of items. I was using the number symbol instead of writing the word number out just because I'm a little bit lazy when it comes to that. But I think everybody knows that that's what the pound sign means. You guys might call it a hashtag. All right, so we need 7 items or less. So n is greater than or less than 7? Less than. Can it equal 7? Yeah, we can have 7 items. We can have 2 items. So it's any number less than 7. 7 or less. And we see this all the time in our everyday lives. We probably don't think of it in a mathy way, which is okay too. All right, scientists have identified over 400 species of dinosaurs. Use D, let D equal number of dinosaur species. So that's very sciencey. All right. So is D greater or less than 400? They've identified over 400. Greater. Does it equal 400? I don't think so, because it's over. Any number over 400 would work. Okay, this is a really good question that I'll probably ask on a problem set and on a test. Is each number a solution to the inequality? Justify your answers. So right there, that's the inequality. If you're wondering what the inequality is, that's it right there. So what we're going to do is we're going to substitute these numbers in where we see the letter B, and we're going to say whether it's true or false. So -8 is greater than or equal to -4. Is that true or false? Is -8 greater than -4? No, it's false. That is false. So that is not an answer. Boo. -3.5 is greater than or equal to -4. Is that true or false? Think about your number line. Look at this. Method 1, we can use a number line. Perfect. Look, this is the exact same question. So here's -4. There's -4 right there. That's the thing that we're looking at. -4. 3.5 is to the right of it. So that would be greater than -4. Is that what that's saying? Yep, so this one's true. All right. -4 is greater than or equal to -4. Is that true or false? It's a weird one, because definitely -4 is not greater than -4. But you have the equal to sign there. You have the equal to sign. So is -4 equal to -4? Is that a true statement? Yes, it is. So this is also true. And it's true because of this line. Are you guys okay? Yeah. How's that? Now you can see the screen. That's good. All right. Okay, so I'm just going to repeat that for those who can now see it. -4 is greater than or equal to -4. It's true because it has that equal to sign there. So -4.5 is greater than or equal to -4. And if we go back to our number line here, -4.5 is on the left-hand side of our goal. So that's less than 4. So this one is false. And then 0 is greater than or equal to 4. So if we look on this, 0 is over here, so definitely 0 is greater than 4. So if we want to verify, we could do a number line, right? And we can decide which side is greater or less than. So that, ladies and gentlemen, is the inequality right there. And these are numbers that we are putting into the letter B to see if it's true or false. I guess I should cross off that one because that one was also false. Oh, we did both of them. Look at that. Method 2. We already did both of them, ladies and gentlemen. We did the number line, which we went over here, and then I did the substitution, which we did right here. What we did here is, this is the substitution. That putting the number into the inequality is the substitution. All right, here we go. Graph each inequality on a number line and write 4 numbers that are solutions of this inequality. Okay, so there's a couple things we need to know here. We need to know that if it has a greater than or equal to sign, you used a closed circle, and we'll go over that. If you use one of those, it's an open circle. And I'll explain that when I'm doing the first example. So you just need to know if it has an equal to sign, we're going to shade in the circle. And if it's open, then we don't shade in the circle. All right. So, and these number lines, notice they have no increments on them. So you're going to have to put the increments on. So if I'll put -5 right here. That's going to be my -5. So let's label some points on here just so we can remember. So negative, if I'm going to the left, they're going to be lower numbers. So -6, -7, -8, -9. So they're lower numbers. And if I go to the right, they're going to be bigger numbers. So -4, -3, -2, -1, and 0. So all I'm doing, ladies and gentlemen, is I am putting my target on here, which comes from right there in the inequality. And then I'm going to label some numbers on either side of it. That helps my brain to see all the numbers. Some of you already understand this, and that's awesome and amazing. But I'm just not that good. Okay, so any numbers to the right are greater than. Any numbers to the left are less than. And if you think of this, can't spell that. If you think of this as temperature, we'd much rather have it be -1 out than -9, right? Like, because -9 is less, it's colder. So if you think of it that way. Okay, so now we're going to put this on a number line. So if we want to put this inequality on a number line, does it have the equal to sign? No, it doesn't in the inequality. So that means we're going to use an open circle at -5. Open circle at -5. Okay, it doesn't have the equal to sign, so open circle. And t has to be greater than. So what, am I going to the right or am I going to the left? I'm going to the right. So then I'm going to use my highlighter for this one. I'm going to say all these points, and I'm going to put an arrow on it. So anything to the right of -5 is greater than -5. So any of those numbers. So we're going to write down 4 solutions. What could t be? And it doesn't have to be numbers on this number line, but there are 4 here. What are some solutions in this arrow here? What's a solution? -4. -4 is greater than -5. So I could write that. I could write 0. What if I wrote 10? Does that still work? Yeah, because it's still greater than. And I'll pick another one. Maybe I'll pick -2. Because all of those fall in this arrow here. Now, I extended like 10 is off this, obviously. But we know 10 is greater. Well, 10 is definitely greater than 0. Okay, so here we go again. We're going to do the next one. Everybody ready for this? So the first thing I'm going to do is I'm going to put my target down. My target is -2. And then I'm going to write numbers less than and greater than. So my less than would be -3, -4, -5, -6, -7. And so these are increments, so they have to go in the same pattern. And this one would be -1, 0, 1, 2. And so these numbers would be greater than. And these numbers would be less than. And some people don't need to write that in, and that's perfectly okay. There's nothing wrong with that. I do because it helps my brain. Sometimes dealing with negatives messes me up a little bit, and it's helpful to be able to see it on a number line. So the first thing we do is we decide, do we use an open or do we use a closed circle here? An open circle or a closed circle? The thing that's going to decide that is what kind of inequality we have. Does it have the equal sign? Yes, it does. This one has the equal sign in it, right? So because this one has the equal sign, we're going to have a closed circle at 2. So you see the difference between an open circle and a closed circle? We're going to fill it in. And what that means, because I might give you a number line with this on it, and you have to create the inequality. This, as soon as I see this, I know my inequality has the equal to sign underneath it. Okay, so -2, I like to read it from the x. X is less than, because the small part's pointing at the x. X is less than or equal to -2. I like to read it from the variable. I don't always read left to right when I'm dealing in math. I like to read from the variable. X is less than, because the pointy part is pointing at the x, less than -2. So am I on the left or the right-hand side? X is less than. So we're on the left-hand side. So if I were to pick some values that are less than -2, I might pick -3, -6, -20, -100. I could do those. Or I could just pick the ones that are stated right on the number line. Either way, that will work. Okay. So here we are with a decimal. All right. So I know my circle is going to be closed because it has the equal sign in it. So I know my circle is going to be closed, which is pretty great. I'm actually going to do this one a little bit differently. I'm going to start with whole numbers. So 1, 2, 3, 4, 5, and then -1, -2, -3, -4. But we're dealing with a half. So where does half live on this? It lives in between 0 and 1, right? It lives right in the middle of 0 and 1. And this tells me it's a closed circle. So I'm going to draw a closed in circle there. So these numbers are greater than, and these numbers are less than. All right, I'm going to stop for a minute, and I'm going to ask you to think about it yourself. I'm going to ask you to put your arrow on. So you're going to read this, start at the variable, and which way is this pointed? What does the big N tell us? What does the big N tell us? If we go right back to the cover, what would we read? Right? Would mean greater than. So where would you put your arrow? Take a second, put your arrow on. I'd use pencil just in case you're not correct, because you can always erase it. All right, I'm going to show you what my answer is. Let's see how confident you are with your answer. Did you get that? A is greater than. I always read from the variable. So A is greater than or equal to 0.5. So my arrow is going to be pointed at these numbers. So I'm going to pick 4 numbers in here. So I'm going to pick 1, 3, 5, and 20. 20 is way off the number line, but it still works. Okay, this one's really hard to see as a fraction. This one's really hard to see as a fraction. So I think I would encourage you to change it to a decimal. All right, so if I were to change this to a decimal, in my handy dandy calculator, I'm going to go 25 divided by 3, and I'm going to get 8.3 repeating. So I'm going to rewrite this. P is less than 8.3 repeating. All right, so anytime I have a decimal, I usually use whole numbers along my increments, and then I put the decimal in between them. So I'm going to start here. I'm going to go 8 and then 9, because I know that 8.3 is somewhere between 8 and 9. So this would be 10, 11, 12, 13, and this would be 7, 6, 5, 4. So do I have an open or closed circle here? Open. Okay, so we're 8.3, so we're not quite at half, but we're a third. We're 1/3 of the way. So I'm going to do an open circle right there. So I know that these numbers are greater than, and I know that these numbers are less than. Which way does my arrow go on the line? Do I go to the left or do I go to the right? P is less than 8.3. Left or right? Where are my less than numbers? They're left, so I'm going left. So a couple of things you're going to see questions like this to put on a number line and give me the inequality. I'm going to be looking for the use of the right open or closed. I'm going to be looking for your arrow going in the right direction, or sometimes I will give you the number line and expect you to write the inequality. Does that make sense to everybody? Everybody's good with that? The open and closed is something that we have to remember. All right, I put these, this is not part of the assignment, it's just kind of like a summary of everything that we did. If x is greater than 1, my numbers are going to go to the right. If it's less than -1, they're going to go to the left. If it has the equal to sign, I'm going to have a closed circle. If I'm going in between two numbers, I'll have open and closed circles on the end. We're going to get here, but maybe not today. And then this is your assignment for today. Pretty straightforward, easy peasy. Okay, you all seem super excited.